You are watching Cold Fusion TV.
Welcome to another episode of Cold Fusion TV. Today we'll be taking a look at the Galaxy Note 3's performance using augmented reality. We'll take a look at how powerful this phone is compared to other phones of today. But first, some background information. The Galaxy Note 3 features a Snapdragon 800 system on the chip. The chip is built on 28nm die shrink technology and features 4 Krait 400 cores clocked at 2.3 GHz each. One of the keys to the chip's performance is the Adreno 330 graphics processing unit, or GPU for short. The Adreno 330 is a real step forward in mobile technology, boasting 50% more power than the Adreno 320 used in phones like the HTC One and Galaxy S4. So what does this all mean? The Snapdragon 800 is unprecedented power in a small, efficient package. For comparison's sake, this is an NVIDIA 8800 GT PC graphics card from the year 2007. It was one of the first graphics cards to be able to play Crysis on max settings. When it comes to pure number crunching, this is only just under 3 times more powerful than the Adreno 330. Obviously the Galaxy Note 3 falls behind when it comes to the number of triangles and polygons that it can process, as well as things like shader technology and all that kind of thing. But the main thing is the size. Just look at the difference between the chip in the Galaxy Note 3 and that massive card with its heat sinks, fans, not to mention that it consumes a massive 175 watts of power while idling. Even though it's a bit like comparing apples and oranges, I found the numbers quite interesting. Okay, so here's how it's going to work. The phone has to render as many objects as possible using augmented reality without a software crash or error. We'll be able to see how hard the phone is working in real time. First up, let me demonstrate the setup. If you're a subscriber, you'll probably know what's going on here, but just in case you're new, it's basically a Galaxy Note 3 connected via HDMI out to a 29-inch LED monitor. We're going to be connecting a Bluetooth keyboard and mouse to navigate around the interface. Speaking of the interface, it's still Android, but it's kind of a custom UI that I've put together to make the phone look a little bit more modern. Samsung phones just look terrible with TouchWiz. Moral of the story, get rid of TouchWiz. I've got an application called Tiny Apps, and it's basically a suite of little apps that kind of float around. For example, this is a music player, and say I just want to minimize it, I can do that. If I want to move it somewhere else, I can just drag it and move it. You can probably notice those red bars up there, but we'll get to that a tiny little bit later. But in this, there's also a place for recent apps, which comes in handy because there's no real way of accessing the recent apps menu using a mouse. There's also an alternative app drawer here, and let's use that to navigate to the app that shows you the CPU monitor. This app is called Micro CPU Monitor, and as you can see there, I just disabled it. So those red bars basically just show you the 4 cores of the CPU, and basically it's 4 lines, 4 cores. So one line represents a single core. So if we flip around through the interface, you can kind of see it jumping around a little bit, and then it settles down when we stop moving. So it's pretty cool to just see that universally wherever you're at. Finally, that main sidebar is an application called Glovebox. Anyway, so let's move along and see how the CPU reacts to web browsing, and then we'll get straight into the testing. So for the web browser, we're going to be using Dolphin Browser here, but an interesting thing to note actually would be that this is all at full 1080p out, guys, so it's quite a lot of pixels to push to this external monitor. And you'll notice that the web browsing is actually still pretty smooth, and even flipping around the interfaces and everything beforehand was so much smoother than the Galaxy Note 2. Galaxy Note 2 could just do it at 720p, so this is pretty good. And so moving on to the web browsing, we're just going to search some images here. So we're pulling up this 90s picture of Jackie Chan. It's actually just the first thing that came to mind because a mate of mine showed me this picture, and something about it just makes me laugh. So opening it up, we can, just like the desktop version of Google or whatever, you can go in and zoom around, and of course it holds its speed when you just want to flick things around. So things will be starting to get pretty interesting in a second with augmented reality. We're basically just using this picture as a basis of the fundamentals of how augmented reality works before we load up some models and get into the real testing. I would just like to add that in the time of using the Galaxy Note 3 as a computer basically, it wasn't as bad as you would expect. Things actually worked a lot smoother and it was a lot more responsive than the Galaxy Note 2 actually. And of course, in the future I'm going to be doing that video of the scenario where your computer has indeed crashed or doesn't work, or you don't have it for some reason or another. And we're just going to ask the question, with the help of some PC-like apps, would the Galaxy Note 3 be a suitable temporary replacement? Okay, so you're probably wondering what on earth is going on, what am I seeing here? So this is the virtual 3D version of the 90s Jackie Chan that I downloaded from the internet beforehand. So basically you can resize it with your fingers, so now I'm using a touchscreen, and also with the mouse. And you'll see in a second how this all fits together with augmented reality. So there's going to be a little tracking marker displayed on a screen. The Galaxy Note 3's camera is going to be pointed at the screen, and this little Jackie Chan will automatically track to that marker. And then it will be able to move in real time with the virtual scene, so it becomes part of that virtual reality. And that screen you're seeing is Asus Transformer Prime, and it's basically just a web page with that tracker loaded up, and it automatically knew to stick to that tracker and start tracking. Alright, so let's begin the testing, shall we? So first we're going to load up a very high resolution model of the CEO of Augment, which is this app that I'm using right now, and once it loads up you'll be able to see that the detail is indeed quite high. So if you take a close look, just say let's look at this guy's jeans textures and his jeans, they're actually quite high resolution, and this task looks effortless on the Galaxy Note 3, but if we start comparing it to other phones such as the HTC One with 50% less GPU power, the frame rate drops ever so slightly. The Lenovo K900's GPU is noticeably slower, and it kind of has a little bit of trouble keeping the high frame rate. And then moving on to the Galaxy Note 2, the Mali 400 GPU in the Galaxy Note 2 just really has quite a lot of trouble keeping track and keeping that high frame rate, so it's not really an acceptable experience. It's pretty cool to see the advancements that the tech industry makes in just 1 year. It's not bad, considering that the Note 3 is pushing this out at 1080p as well. Alright, we're going to take a quick break and then we'll be back after this.
You are watching Cold Fusion TV.
Okay, welcome back guys. So enough with the baby games, let's actually try and make this thing freak out and crash. So I've gone ahead and uploaded another object, but this time it's actually an animated object. And as you can see, it tracks still pretty well, frame rate keeps up, pretty much the same as it was last time. But it's just really an interesting effect to have that tracked in real time. I also just want to remind you guys to take a note of the top of the screen. So as you can see, the CPU bars kind of go nuts when you do certain things. So it's interesting to see how things react when I actually pan around with the camera or actually grab an object and move it around. It's just cool to see how the cores actually react in real time. So let's go ahead and add another object. I went ahead and added this Android kind of dude thing, and it kind of didn't really do much, so just went ahead and added the next object straight away. And this was actually just an animation of a ball rolling down a slope through a brick wall. That didn't really do much, so everything was still quite simple for the Note 3. I added a helicopter in the background, don't know if you can see it, as well as this box of dishwashing liquid, because I don't know, there's nothing better. And I got an animated man and some other stuff in the background, but it didn't really do much until I added a car. And this car actually started slowing the GPU down because it was actually quite high resolution, and on the interior of it you can actually see all the details and stuff there, so a lot of calculations happening, and that kind of taxed the GPU, so we're starting to see the signs of a GPU bottleneck. But really the frame rate wasn't that bad. Like compared to the Galaxy Note 2, that couldn't even handle just that one model. I'd also like to apologise for the random selection of stuff on the screen. There's quite a lame choice of models to choose from in the augmented reality app, but it's just for demonstration. Anyway, when I went to upload another car of a similar complexity, it gave me this error. Impossible to start camera. You may have to reboot your device. I don't know if it was the software or the hardware, but that's grounds enough to say that the phone failed the test. When I clicked OK, it just reset with just the one car. So you've seen what the phone can do, but at this point you'll be asking, why did I choose augmented reality to look at GPU performance? One reason, because it's kind of engaging, and the other reason is because I figured augmented reality is becoming more and more common these days. And with Google Glass being released next year, it may just hit the mainstream in the next 5 or so years. If such a scenario was to happen, we can safely say that the Note 3 is future-proof in this application. The speed in which the Note 3 tracks objects kind of gives the scene that bit of extra realism. Okay, so for all of you traditional folk out there, let's take a look at where the Note 3 sits in the context of pure gaming and graphics performance. So what you're seeing here is the second level of the Anomaly 2 benchmark, and the Anomaly 2 benchmark is one of the most intensive graphics benchmarks that I've actually seen. Unfortunately it doesn't have a frame rate counter, but you don't really need to see that to actually see that the Galaxy Note 2 is really struggling and not pushing those pixels, and the GPU is not really getting that frame rate up, and the CPU is still working hard but not really getting there. So the Galaxy Note 2 just really falls behind the Galaxy Note 3 once again in performance, even in this graphics benchmark. So what we're looking at here is GFX benchmark, and as you can see, the Note 3 actually is just a tiny bit smoother than the HTC One, but they're both doing pretty well, and you'll be able to notice that the HTC One CPU cores actually go all the way to the end, and the Galaxy Note 3s don't, well, they rarely get there. And just as a side point, this benchmark is actually really cool because it gives you the average frame rates from around the world, from anything from the best graphics card in the world using a PC to any cell phone you can really think of. So I've just been listing some of the frame rates so you can get a wider understanding to where the Galaxy Note 3 sits. So all of these devices are running on exactly the same benchmark, so that's the 1080p off-screen benchmark. This benchmark just tests how the GPU handles 1080p and pushing all those pixels out to a virtual 1080p screen. So it's all fair game, it doesn't matter what phone you have, it's all an equal flat playing field when you have an off-screen virtual screen. So as you can see, these are some of the world's most popular phones, so you may have one of these phones or you may have had one of these phones, so you can just kind of see where all the relative performance actually sits. And if you ask me, I think there's a drastic difference actually between some of the phones last year and this year. One of the observations that I made was HTC seems to be very efficient in their CPU usage, so it only uses 1 core on idle, whereas Galaxy phones use 4 cores. Despite this, the battery life on the Galaxy Note 3 is a whole lot better. HTC really needs to put higher capacity batteries in their phones. So you guys have seen just a tiny demonstration of what's possible with this kind of power on this device. But to be honest, none of this would have been possible without the Snapdragon 800 system on a chip. So the bottom line is, it's not really about Apple, HTC, Samsung, LG, Sony, Motorola or any other brand, but it's about the chip manufacturers, the researchers, the engineers, scientists, and all those people working together to create such power in such a small package. Those guys are the real heroes. And on that note, that just about rounds out this episode. Coming up next time on Cold Fusion, we got the full Galaxy Note 3 review. That one's going to be a good one, so be sure to subscribe not to miss that. And then we also have the 3D UI tutorial after that. So, if you're passionate about high performance and want to spread the word about the best that's out there, make sure you share this video. As usual, don't forget to rate, comment and subscribe. Cheers guys.
Cold Fusion. It's new thinking.
I'll grow too hard, your every dawn. These days I've been getting wrapped up so tight.